Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, we're going to be talking about probability, which is a topic that appears on both the arithmetic reasoning as well as the mathematics knowledge subtest of the Armed Services Vocational Aptitude Battery. More specifically, we're going to talk about these 8 rules of probability with which you need to be familiar. But before we do, let me say this. On the ASVAB, you're not allowed to use a calculator or a reference sheet. So everything you see in today's video, you're going to have to commit to memory. And in addition, you're going to have to be able to perform all the arithmetic by hand. Similarly, I also want to mention that in order to get the most out of this video, you should make an effort to pause the video at some point, work on the practice problems in this video on your own, and then resume playing the video to check your solution. So all those things being said, let's go ahead and get started with today's video. All right, so to start today's video, let's ask ourselves, what is probability? In short, probability is the likelihood of an event occurring. So for example, the probability, according to this 7-day forecast, of it raining on Saturday is, as we can see, 60%. The probability of event A occurring is written as PA. Again, this is just standard notation for probability, and throughout this video, we're going to be writing using this notation. And then finally, we have to realize that probabilities are always between 0 and 1 inclusively, meaning that probability can be 0 and probability can be 1. Okay, so let's look at this example again. According to this meteorologist, there's a 60% chance of it raining on Saturday. Of course, we can express percents in decimal form as 0.6. And as we can see, all these probabilities given are in fact between 0 and 1. Okay? All right, so prior to doing any examples in today's video, I want to give you an overview of all the basic rules of probability. First, as we discussed, I want to point out again that the probability of an event occurring is always going to be between 0 and 1. If as you work on these problems, you get something that's not between 0 and 1, chances are you've made a mistake. Second, I want to point out that the probability of an event and a possible event occurring is 0, and that can be written as P naught equals 0. Third, I want to point out that the probability of a sure event occurring is just 1. That can also be written as P of S equals 1. Again, number 2 says this event's never going to occur no matter what. And number 3 says this event's always going to occur no matter what. Okay? For the bulk of the video, I'm going to be giving you examples in regard to these topics, starting with the probability of a single event occurring is given by the number of ways it can happen by the total number of outcomes. The probability of an event not occurring can also be found by doing 1 minus the probability of that event occurring. The probability of 2 events occurring can be written as probability of A and B, which equals the probability of A times the probability of B. As we discuss number 6, we're also going to discuss the idea of independent and dependent events. And then finally, we're going to end today's video by discussing exclusive and non-exclusive events, that is probability of A or B. And as you can see, those have 2 different formulas depending on what type of event you have. Probability of A or B for an exclusive event is probability of A plus probability of B. That's pretty simple and straightforward. And then if you have non-exclusive events, the probability of A or B becomes the probability of A plus the probability of B minus the probability of A and B. I'll say this, right now this may look very complicated, but as we work our way through examples, this is going to become very intuitive, including these ones at the very end here. So just be patient. Sometimes probability takes people longer than others to pick up, but I promise we're going to do enough examples for you to learn this pretty easily. All right, so let's start today's video by talking about how to find the probability of a single event. Again, you may recall that that can be found by finding the number of ways that event can happen and dividing it by the total number of outcomes possible. For this example, we want to find the probability of rolling a 4 on a 6-sided die. So that's probability of rolling a 4 equals, again, a 6-sided die has 6 faces. So in total, there are 6 possible outcomes. Again, you can roll a 1, a 2, a 3, a 4, a 5, or a 6. That said, there's only one way you can roll a 4. Okay, so the probability of rolling a 4 is 1 over 6. All right, in this example, we want to figure out what the probability of selecting a green marble and a bag that has 5 green marbles, 9 red marbles, and 6 blue marbles. Again, we want to find the probability of selecting a green marble. So we want to figure out the total possible number of outcomes. That's pretty easy. All we're going to do is count how many marbles are in the bag because that's all of your outcomes. Again, there's 5 plus 9 plus 6, which is 20 possible outcomes. Your odds of selecting a green marble are 5 since there's 5 green marbles in the bag. Of course, we can reduce this if we wanted to by dividing the numerator by 5 and the denominator by 5. 5 divided by 5 is 5. 20 divided by 5 is 4. So your odds of picking a green marble are 1 out of 4. Okay? All right, in this example, we're being asked to find the probability of getting a tails when you flip a coin once. Again, we could write that as probability of getting a tails. Again, there are 2 possible outcomes when you flip a coin, either heads or tails. So we know there are 2 possible outcomes. Only one of those is tails, so we know that that's going to be 1/2. So in other words, your odds of getting a tails is 1/2. All right. This example asks us, what are our odds of selecting an ace of spades from a standard deck of playing cards? Deck of playing cards has 52 cards, so our probability of picking an ace of spades, and I'll call that AS, is going to be out of 52. Again, we're going to pick one card from 52. And if we take a look, there's only one ace of spades in the entire deck, so there's only one way we can pick an ace of spades. Okay, so our probability, in other words, of picking an ace of spades is 1 out of 52. All right, so now let's talk about finding the probability of 2 or more events. Again, that can be written as probability of A and B equals the probability of A times the probability of B. Once we do a few examples of this, we're going to talk about the idea of independent versus dependent events. But that said, let's take a look at our first example. It says, what is the probability of rolling a 4 on a 6-sided die 2 times in a row? So again, that's going to be probability of A and B, which we know is probability of A times the probability of B. If we want to write this to mirror the word problem, that can be probability of 4 and 4. Okay, again, the odds of rolling a 4, as we previously saw, were 1 out of 6. And again, the probability of rolling another 4 is 1 over 6, so we just multiply these together. This becomes 1 over 6 times 1 over 6. And again, when you multiply fractions, you multiply straight across. 1 times 1 is 1, and then 6 times 6 is 36. Therefore, we can see the odds of rolling Two fours in a row is 1 over 36. All right, so this one says, what is the probability of getting heads 3 times in a row when you flip a coin 3 times? Again, probability of two events is probability of A and B equals probability of A times the probability of B. In this case, we can write this like this: probability of heads and heads and heads. So we know this is going to be probability of getting heads times the probability of getting heads times the probability of getting heads. Okay, so let's work this out. Again, the probability of getting heads is 1 over 2. Again, you have one chance of getting a heads, but you can get heads or tails per flip, and that's going to be times 1 over 2 times 1 over 2. Again, we're multiplying fractions. When you multiply fractions, you multiply straight across. So this will become 1 times 1 times 1, which is just 1. And then 2 times 2, which is 4 times 2, which is 8. So your odds of rolling or flipping heads 3 times in a row is 1/8. Okay? In the two previous examples, it should have been obvious that what we did per occurrence didn't affect the outcome of the other occurrence. When you rolled the dice, the first roll didn't affect the second roll in any way. But let's take a look at what happens when our first occurrence does affect the second occurrence. So this example says, what is the probability of selecting a blue marble in a bag that has 5 green marbles, 9 red marbles, and 6 blue marbles twice in a row? Assume you don't replace a marble after the first selection. So this should tell you that our first selection is going to affect the odds of our second occurrence. So again, we're still dealing with this probability of A and B equals probability of A times the probability of B. That said, let's rewrite this so it's applicable to the problem. Again, we want to find the probability of selecting a blue and then another blue marble. Okay, the odds of selecting a blue marble, that's going to be 1, 2, 3, 4, 5, 6 out of 20. Again, your odds of reaching in and picking a blue marble are 6 out of 20, since there are 6 blue marbles in the bag and 20 marbles in the bag in total. Now that said, we pick our first marble and then don't replace it. So we're going to multiply this by, again, we didn't replace that marble, so this drops down to 19. Again, there are only 19 marbles in the bag now. And as far as probability goes, we have to assume that we picked a blue marble the first time. So this goes from 6 to 5 as well. Okay? So now all we have to do is multiply straight across. And this becomes 6 times 5, which is 30. And then 20 times 19, which I'll work off to the side here. 9 times 0 is 0. 9 times 2 is 18. Before we start math with this 1, we have to add a 0 placeholder. 1 times 0 is 0. 2 times 1 is 2. Let's add 0 plus 0 is 0. 8 plus 0 is 8. And then 1 plus 2 is 3. So we can see the odds are 30 out of 380. And we can reduce this if we wanted to. But we're not going to. Again, I'm just trying to show you probability, not how to reduce fractions in this video. Okay? So let's look at another example where the first choice is going to affect the outcome of the second choice. in this case, it says, what are your odds of selecting a red card twice in a row from a standard deck of playing cards? Assume you don't replace a card after making your first selection. Okay, so again, we're trying to find this probability of A and B. So we know in general it's going to look like this. Probability of A times the probability of B. Let's write this so it's in accordance with this problem. It's probability of red, and then selecting another red one. All right, so let's think about what we're going to do here. Again, in a deck of playing cards, there are 52 cards. And again, each row has 13 cards in it. So there's 13 here, 13 here, 13 here, and 13 here. As we can see, there are 2 rows of red cards. So there are 13 plus 13 are 26 chances of you picking a red card from a deck of 52. So we took care of this first occurrence. The odds of picking a red on one draw are 26 over 52. Now again, we're not replacing that card that we took the first time. So again, now there are 51 cards in the deck, and we have to assume for probability that we picked a red card. So now we have to assume there are only 25 red cards in the deck now. So again, this is going to become 26 times 25 over 52 times 51. We're going to work these off to the side. This is going to be 26 times 25. And again, I'm not going to reduce this fraction. That's beyond the scope of this video. On the ASVAB, you would have to reduce these fractions. 5 times 6 is 30, carry your 3. 5 times 2 is 10, plus 3 is 13. Add a 0 placeholder. 2 times 6 is 12, carry a 1. 2 times 2 is 4, plus 1 is 5. This is 0 plus 0, 2 plus 3, which is 5, and 1 plus 5, which is 6. So this is 650 over, and then we have 52 times 51. 2 times 1 is 2, 1 times 5 is 5, add a 0 placeholder. 5 times 2 is 10, carry your 1. 5 times 5 is 25, plus 1 is 26. Let's add. 2 plus 0 is 2, 5 plus 0 is 5, 6 plus nothing is 6, and 2 plus nothing is 2. So this is 650 over 2652. By doing this long division, you can figure out what that percentage is. But in short, these are our odds of picking 2 red cards in a row. Okay? All right, so let's talk about the final rule of probability for today's video. That is, let's talk about how to find probability of exclusive and non-exclusive events. As we can see, probability of A or B equals probability of A plus the probability of B for exclusive events, whereas the probability of A or B is probability of A plus the probability of B minus the probability of A and B for non-exclusive events. Let's take a look at an example of each of those. This first example says, what is the probability of choosing one card from a standard deck and getting either a Queen of Hearts or an Ace of Hearts? So these are exclusive events because you can either pick an Ace of Hearts or a Queen of Hearts. There's no overlap between those choices. Okay? So, and once we do an example where there is overlap, that should become much clearer, but let's write this. This is going to be probability of selecting a Queen of Hearts or an Ace of Hearts. And of course, that's going to be probability of Queen of Hearts plus the probability of selecting an Ace of Hearts. Okay, so let's work on that. The probability of selecting a Queen of Hearts, again, there's only one of Queen of Hearts in the entire deck of 52 cards. And similarly, there's only one ace of hearts and the entire deck of 52 cards. So in this case, we're adding their two probabilities together, which we can do if they have the same denominator. In this case, both denominators are 52. So this becomes 2 over 52. In other words, the odds of picking a queen of hearts or an ace of hearts is 2 over 52. If you wanted to figure out what this was in terms of a percent, you can do 2 divided by 52. Okay? All right, so let's take a look at an example of a problem in which we're dealing with non-mutually exclusive events. And this one says, what is the probability that a card chosen from a standard deck will be a jack or a heart? So that looks like this. Probability of selecting a jack or a, let me try to draw one for you, heart. Okay? Again, we know these are non-mutually exclusive events because I've told you, but we're going to take a look at the reason why in a minute. So we know this is going to be probability of jack plus the probability of heart minus the probability of jack and heart. And let's see why, okay? All right, so if we look at our standard deck of playing cards here, we can see that we have 4 jacks in the deck. Okay, so there are 4 jacks in the deck. The odds of selecting a jack, in other words, are 4 out of 52. Okay? And if we go right here to our row of hearts, we can see that, again, there are 13 cards with heart faces. So we can see the odds of picking a heart are 13 over 52. And if we take a closer look, we can see that we have this jack, which is also a heart. And as we can see, there is overlap between these two events. So in light of that, we know they're non-mutually exclusive, which is why we have to subtract out this odds, the odds of picking a jack and a heart. And again, there's only one jack that's a heart, so this is going to be, that should be 52. 1 out of 52. Okay, by working this out, we can figure out what the odds of picking a jack or a heart are. Again, these all have the same denominator, so we can write this like this. 4 plus 13 minus 1 over 52. And this becomes 4 plus 13, which is 17, minus 1, which is 16 over 52. And again, if you wanted to convert this to a percent, you can do 16 divided by 52. Okay? So that's it for today's video. I hope you found it helpful. Again, I just went over some of the basic rules of probability, which you do have to know for at least one question on the ASVAB. If you like the content I'm creating, please consider subscribing to my channel. In addition, you're more than welcome to leave feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.